Man, oh man, are you going to love me today? Today, we're going to learn the power rule, which is kind of a slick little deal. If you were in class and you're just watching this as a review, you already know this is going to be amazing. If not, wait to be amazed. What we did in class is we went ahead and did review of the difference quotient and the big homework assignment from yesterday. So remember my rule on showing some nice work. I'm looking for that. Obviously that you got the right answer. Okay, and so now we're just going to jump into this power rule. Okay, so I just made up some functions here for us to work with. Now the power rule works really slick with polynomial functions. So quadratics, cubics, quartics, that kind of thing. Works really slick with that. And that isn't always what we're handed, but it works on these, so it's a nice shortcut for that. Now, this is pre-calculus, so I show you a few little things. When you get into calculus, you're going to find there's a lot of rules that can be used in different scenarios. This one's called the power rule. And what it says is that, and we proved it in class yesterday because I gave people different functions and they went and did our difference quotient. And so what we have learned though is that you can find the derivative of a polynomial function by simply taking the power times the coefficient. That would be a 12. And then the x is going to be dropped by 1 unit. So it used to be a 4, now it's a 3. And then we do it again. So now you take the power times the coefficient. So that's going to be a -6. X to the, now reduce it by 1, be a 2. All right, let's keep going. The degree times the coefficient, so that's a 10. Power drops by 1, so it's going to be an x to the first or just an x. Okay, now let's look at this one. What's the power on this one? Well, it's assumed to be a 1. And what's the coefficient? Also assumed to be a 1. So when you take the 1 times the 1, you just get a 1. But now it's going to be an x to what power? Well, if you reduce it by 1, it becomes an x to the 0 power. But x to the 0 is really just 1, so we wouldn't bother writing that at all. It's just a 1. Okay, which means when we get to this next term, it's a -3. That's assumed to be a -3x to the 0, if I were to write that. And then when I do my power rule, I'd have 0 times -3, which is just 0. And it wouldn't even matter about the x because the 0 is going to get multiplied and it's going to go away. So this right here is the derivative. If you're feeling ambitious, you can check it. Okay, so see if you can do, I did one for me and then I have one for you. See if you can do this next one using the power rule. Go ahead, I'll give you a minute. Pause the video while you're doing it. Okay, so here's what I've got. Notice on this one that the 5 goes away. The constant always is like an x to the 0, so the constant's always going to drop off. Okay, what I'd like you to do is take a minute. Let's go back to yesterday's homework, and we're just going to check a few. Not like do it for the first time and go look and see what the answer is, but let's pick one out. So looking through, if you have to go dig for it, then go dig for it, but I'm just going to grab out, I am looking at, let's find a nice polynomial one. One of those that you had to do like well, there's a good one. Let's look at number 6. Look at your answer for number 6 on your homework. If you need to pause it and go dig it out, then go do that, because I will reference your homework a few times. Okay, so now looking at that, can you see using the power rule would get you a 12x squared plus a 2, and then it'd be an x to the 0, so that would go away. Did you get 12x squared plus 2? All right, nice. So any of these that were polynomials on your homework, I would highly recommend you go and check them. Now, I won't give you any credit for them if you don't have the difference quotient worked out nicely for them, but it's a great check. So on your test, I'll have some that you have to do the difference quotient, and then I'll have some where you're just doing the power rule. Okay, now this works really great for polynomials. It actually can work for some other types as well if they're written just right. So here's some that are the fraction ones. We did some fraction ones on our homework. So if you look at this, what you would have to do is take this and rewrite the function. Notice that I'm just writing f of x. I'm not writing the derivative. In red is the derivative. In black is the actual original function. What I would have to do is I'd have to rewrite this as a 2x to the, what power do you think I would take that x to? Remember that when you make your power negative, that's what pops it to the denominator. So this is really a 2x to the negative 2 plus 3x to the negative 1, and then a minus 5. All right, when you write it like that, it's really not a polynomial function, but the power rule still works on it. So to find the derivative, we would take the power times the coefficient, negative 4, and then you would have to reduce the power by 1. What I mean by that is I mean subtract 1. Up here above, when it was a 4, we subtracted 1 to get a 3. 3, we subtract 1 to get a 2. But be careful, because if you have a negative 2 and you subtract 1, what do you end up with? It's a negative 3, actually. Okay, let's try again. Multiply the power times the coefficient. That gets you a negative 3x to the, and you have a negative 1, subtract 1. That's going to get you a negative 2. And then on this last one, it's a constant. That's going to drop off. And then your final answer, you actually have to go back and put that back into fraction form. So this would be a negative 4 over x cubed. And this would be a minus 3 over x squared. And that's how we would write our final answer. Okay, so I have one for you to try now. Pause the video for a minute, see if you can do it by yourself. All right, this is what I've got here. Hopefully you've got the same thing. I just threw a 742 out there to freak you out. Doesn't matter, does it? It's just going to go away. Okay, I've got one more thing to try. We can even make the power rule work if we're doing radicals, because you can write a radical with a power. So what we would do on this first one, we would have to rewrite that as a 6x to the 1/2 power. And then you go through and you do your power rules. So change it to a derivative. Power times the coefficient equals 3x to the, now if you take a 1/2 minus 1, it's a negative 1/2. So what's going to happen is that's going to end up being a radical in my denominator. So it's going to be 3 over the square root of x. And then in all honesty, we should, I know on your worksheet yesterday we didn't always rationalize, but we certainly could, and do this to it. Final answer, 3 root x over x. Okie doke. See if you can try the next one on your own. Pause the video. Okay, did you cheat? Did you come back too early? Did you never pause? Got to try it. All right, here we go. So first thing I did is I changed my cube root to a 1/3 power. And then when I did the power rule, a 1/3 minus 1 actually ends up getting you a negative 2/3. That's a little trickier. That would be the same as the cube root of x squared, but it's in your denominator. And then, kind of testing your algebra here, do you remember how to rationalize this? Because it's a cube root, you've got to put something in here. This is called the radicand. The radicand has to multiply to get you a perfect cube. So I really only multiply by the cube root of x, because that's going to get me a cube root of x cubed, which is x. And then on the top, I have a 2 cube root of x. All right. Now, we really won't get too much into the radical ones, but definitely we'll do some of the fraction ones. All right. So let's look at what your homework is going to be like tonight. And so grab that worksheet out. I'm just going to do like one from each set with you. Okay. On this set, it says, this is number 8 on your homework. It says, find the slope of the line tangent to the graph at each function at the given point. Okay, so now here's the deal. I'm not going to give you a whole bunch of, these are easy peasy to do. So really what we're doing today on your homework is that day 3 worksheet. But instead of having to find the slope of the tangent line or the equation of the tangent line and all of that stuff, instead of finding that with the difference quotient, we can quickly find the derivative and then boom, get into the other stuff. All right, so it says find the slope of the tangent line. All right, remember what that means. The slope of the tangent line is really just the derivative. I have to find the derivative at a particular spot. Okay, so the first thing I'm going to do is find the derivative using my power rule. Only doing power rule today. So 2 times 1/2, that's just a 1x, and then the 12 goes away. Well, how nice is that? Okay, that's a pretty easy derivative. But I want to find it at a particular point. Now, if you think through this graphically, going clear back to day 3 here, that this is a quadratic that is a little bit wide because of the 1/2, and it's moved up 12. So it's way up here someplace, like that. And then at this particular point, at -3, 16.5, way up here someplace, I'm supposed to be finding the slope of the tangent line. Okay, well, the tangent line would be something like that right there. Now, do you remember how do I find the slope of the tangent line at that spot? Well, the 16.5 doesn't really even matter because really all I need is to find the derivative at this particular x value. The 16.5 is extra information. So what that means was when I put in -3 in for x, I really just get -3. So the derivative at -3 is -3. You can see that it would end up a negative slope. Okay, so if they give you the ordered pair there, but all they want is the slope, you really only use the x value. Okay, let's flip to number 17. On this one, it says, find the equation of the line tangent to the graph of each function at the given point. Okay, now we're going to need that full point. So we start off and we do the same thing. To write the equation of the tangent line, the first thing we need is the slope. So we do that with the derivative. So let's find the derivative. Using our power rule. And then I'm going to find the slope of the tangent line at that particular spot. So I'm going to put in 0.5. So -2 times 1/2 is just a -1 minus 1. So I end up with a -2. So what this is right here is this is going to be the slope that I want. But they also have handed me the ordered pair that I want. So this is my point. This is my slope. And I'm going to go put this into point slope form. The slope is -2. And then they did say that they want the final answer in slope-intercept form. All right, there we go. Okay, last one. This is number 22. It says find the derivative of each function. Okay, going to use the power rule. Recall that this is the slope of the tangent line. Yes, we've got that. Find the coordinates of the point at which the slope of the tangent line equals the designated slope. Okay, so notice they're not giving us an ordered pair anymore. What they're wanting us to do is figure out where this might happen, where the slope in this example would equal 0. All right, so let's start off. Let's go ahead and do our derivative. Okie doke. Now, what they're saying is they want to find where would it happen where that slope equals 0. Well, I'm just going to set it equal to 0. How about that? And then go solve for x, and then that would be where it happens. Now, there's a couple ways if you want to factor this, or maybe you want to add the 36 over here, and you can do square roots. Either way works. But if you choose to do square roots, don't forget that when you square root both sides, what do we got to put there? A plus or minus 2. Okay, so what that indicates is that this is going to actually happen in 2 different places. It's going to end up at x equals 2, and it's going to end up at x equals negative 2. Now, they want more than just the x value. They want the coordinates of the point. So if x is equal to 2, then I need to know what's the y value on the function that would match that. So if you're looking for the y value, then what you have to do is you have to take that 2 and plug it back into the original. So I do f of 2. And so 2 cubed is 8 times 3, that's 24. Minus 36 times 2 is 72. Okay, so that means it would end up equaling a negative 48. Okay, so that means I have an ordered pair 2, negative 48. That's one of the places it happens. Okie doke. Let's put in the negative 2. And again, you're putting this, because you're looking for the y value, it goes back to the original function. So negative 2 cubed is negative 8 times the 3. That's a negative 24. And then you're going to end up with a positive 72. So in this example, it's going to end up being a positive 48. So then the other place that this slope is going to end up being 0 is at negative 2, 48. So these are your 2 spots that they're looking for. Okay, that should give you a nice sampling of the different types of problems you're doing on your homework. You should have your power rule worksheet. Go to town. Good luck.